Um, so we're going to look in this video, which is video number 3. I want to look at the f of x equals tan function in a little bit of detail. We're going to see something weird, is that as x approaches pi over 2, or 90 degrees, that the tangent of x approaches infinity. And I want to go over why that is. We're going to see that x is equal to pi over 4. The tangent of x is equal to 1. X is equal to 0. The tangent of x is equal to 0. And then if we do the mirror images, we're going to get, like, if we, instead of positive pi over 4, 45 degrees, negative pi over 4, we're going to get tangent. They're going to be opposite. And then finally, we see that as x approaches negative 90 degrees, the tangent of x is going to approach, it should be equals minus 1. Tangent of x is going to approach minus infinity. So I want to start with this one right here. Okay. So here we go. I'm going to draw a triangle. It's a right triangle. That's 90 degrees. This is 45 degrees. That means this angle here is also going to be 45 degrees. We have what's called an isosceles triangle. Equal angles, if the angles are equal, so are the sides. So this is equal to this. So let's say this is our opposite to the angle. This is going to be our adjacent. And so the tangent of pi over 4, or 45 degrees, is opposite over adjacent. These are equal because it's a 45-degree triangle. So we can think of it as opposite over opposite. That's going to be 1. So that's how we get that. Now what's going to happen, as this angle gets closer to 0, the adjacent side is going to get really big. The height here is going to get really small. So this ratio, tangent, remember x, is equal to opposite over adjacent. As this side gets really big, this ratio is going to get small, close to 0. Okay, so just keep that in mind. We'll go back over that. As the angle x gets bigger, this side's going to get bigger, this side's going to shrink, so that ratio of opposite over adjacent is going to be really big. Okay, so we're going to look at that in the next couple of pages. But I want to look at a minus 45-degree angle, and remember, if we're going to talk about negative angles, we really need to look at the unit circle. So here's minus 45 degrees. We measure it that way. Now this angle's 45. This angle's 45. Again, really pi over 4. So that means that this side is equal to this side. So that means whatever these numbers are, they're going to be the same. And it turns out that the numbers are going to be square root of 2 over 2 minus square root of 2 over 2. So when I do the tangent of minus pi over 4, opposite over adjacent, those are going to be equal. These two are going to be equal. The angles opposite the sides. Opposite over adjacent is equal. That's going to be, except for that's going to be a minus sign. So we're going to have minus y over x, that coordinate over this coordinate. The same on the top and bottom except for a minus. That's going to be minus 1. So that's why we have the tangent pi over 4 is 1, tangent minus 1. They're opposite. Okay. And that's going to happen. That's going to continue to happen. So one more thing, and then we're going to look at Desmos. I know this is a little abstract. So as our angle approaches pi over 2, this is what the triangle looks like. This is going to be the side opposite. That's the adjacent side. The opposite is much, much bigger than the adjacent. So the tangent of x is going to be opposite over adjacent. The top is way bigger than the bottom, so that's going to be way bigger than 1. And we'll see actual examples. Now, as x approaches 0, it's going to be the opposite. That's a skinny angle near 0. And The opposite side is going to be short. The adjacent is going to be large. So here, as x approaches 0, we're going to see that the adjacent side is much, much bigger than the opposite. So that means the bottom is bigger than the top. This is much bigger, so that means the ratio overall is going to be much less than 1. Okay, so when you have the double, it's kind of like emphasizing the size difference. Okay, so anyway, I just wanted to kind of point that out, and we're going to look at Desmos in a second. Just one more thing, as I want to look at the tangent x on the unit circle one more time. And I'm going to look at x, and I'm going to look at negative x. This is going to be, whatever that's going to be u, this is going to be u. Whatever what's the y-coordinate v, it's going to be the opposite, but negative, because it's just going to be a reflection, even though my pictures don't show it. So the tangent of x is going to be v, y over u. That's going to be positive. The tangent of negative x is going to be negative v over u, and that's going to be negative. Okay, so a couple of things, just to summarize what we're doing. We're saying the tangent of x is opposite tangent of minus x. That's going to be an odd function. Remember, we talked about that before. Okay. Then also that as x approaches pi over 2, tan x approaches plus infinity. As x approaches minus pi over 2, tan x is going to approach minus infinity. That's because the ratios are going to be big, and we're going to see that in Desmos in a second. So let's go look at Desmos, get a little bit less abstract. Okay. So we're going to look at, I have a table here of values for, and let's just look at these for a second for the tangent. And I have the degrees converted to radians, and then I'm evaluating the tangent. Okay, so notice that when the tangent's undefined, when we have a 90-degree angle, and we've talked about that before, why that is. That's because remember, it's going to be opposite over adjacent, and at a 90-degree angle, there's no adjacent side. It's equal to 0. Okay, but as we get really close to that, the overall ratio is really big. So the tangent of 89.999 is about 57,000 and change. When we go to 89.9, the tangent is about 573. At 89, the tangent is about 57, and it keeps shrinking. When we get to 45, the tangent is going to be 1. And notice as we get closer to 0 that these values get closer to 0. And then when we take the negatives, they're just opposite one another. Okay. So again, I just took a bunch of values, plugged it into the computer, and this is what I got up. And just by looking at that, you can see as that we get closer to 90, the values are getting bigger and bigger and bigger. It's actually going to be an asymptote there. Then when we get towards minus 90 degrees, we're going to get the same thing. Okay, so what I wanted to do next is I want to graph the tangent function. And I want to change I'm going to go to the home space here. Okay, and I'm going to turn on the tangent graph. Now notice that's the tangent graph. Notice that it passes through 0 and starts to rise really steeply. Same thing here. And I'm going to zoom out. And you see you just have infinitely many copies of the same graph. So since it repeats itself, it's periodic. So we want to analyze that. Okay. And notice how the repeating cycle is. It looks like it's going to be, excuse me. It's hard to see here, but if we put an asymptote at x equals pi over 2, and I'm going to make this a dotted line. and let's change the color, you can see that this graph looks to approach the line x equal pi over 2. And again, I'm just going to zoom out, keep zooming out, and you can see that happening. Start zooming in again. You can see how the tangent graph approaches 90 degrees. I'm sorry, approaches the line x equal pi over 2. So I'm going to take this out for now. We don't need that anymore. Okay, we can see that geometrically. So what this means is that x equal minus pi over x equals plus x equals pi over 2 is going to be, sorry, I want to make this a comment. X equals pi over 2 is a vertical asymptote for y equals tangent x. Okay. And let's guess at what the vertical asymptote over here is going to be. You can probably guess it's going to be minus pi over 2, so let's see what happens. Make it dots. Okay. And it looks like it's going to be a vertical asymptote also. So here, so let's go here, add a comment. I'm just going to say x equals minus pi over 2 is a vertical asymptote for y equals tangent x. Okay. So let's just get this back here. And again, if we zoom out, you can kind of see how the graphs run concurrently. That's just because the graph can't be, it loses accuracy. So, but you can see it here. You can see it start to approach. Okay. So basically, that tells us, notice that graphs are undefined at vertical asymptotes. So that means that the tangent, and I'll summarize all this, is undefined at x equals plus and minus pi over 2. Now notice that the graph just repeats itself. And it looks like it repeats itself between minus pi over 2 and pi over 2. So I'm going to find the vertical asymptote over here. And my guess is it's going to be x equals 3 pi over 2. And you can see that it is. Let's change the style and the color. We're going to use asymptote screen. And again, and if I do 5 pi over 2, I'm going to get another vertical asymptote. I don't know why that's darker over here. It just happens to be. Don't know why. Oh, there it goes. There it goes back to normal. Okay. So what we're going to see here is that we have vertical asymptotes at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. And it's going to be the same thing in the negative direction. Let's look. Let's look at x equals minus 3 pi over 2. Again, let's make it dotted. Okay, same thing. So what's going to happen is that, again, I'm going to write it down here, is that x equals plus minus that's going to be a vertical asymptote here. I think I can do that better. Okay. And then plus minus 3 pi over 2 plus minus 5 pi over 2. So basically, these are all going to be vertical asymptotes. Strange function. Notice that it repeats itself. The length of its repeating is repeats itself between minus pi over 2 and pi over 2. So its period is going to be pi in this case, not before like pi over 2, but pi. Okay. So these things are not in the domain. You got to keep that in mind. So we're gonna go figure out what the range is. I mean the domain. But if we look at the range here, remember the range is all the possible y values. It looks like it goes. This part of the graph near pi over 2 goes to infinity. The part towards minus pi over 2 goes to minus infinity. And the graph hits everything in between. So the range is going to be minus pi over 2 to pi over 2. Okay. Now I'm going to go summarize this stuff. So the point of this all was just to get an understanding of the tangent graph. It's really weird. The tangent graph repeats itself every pi units. It's got one cycle between minus pi over 2 and pi over 2, another between pi over 2, it's the same graph, 3 pi over 2, between 3 pi over 2 and 5 pi over 2, and the same over here. So its period is pi. Notice that it goes from minus infinity below, to plus infinity above. That means its range is going to be, that should have been infinity. The range is going to be minus infinity to infinity. Sorry about that. Okay. The domain, it looks like it's everywhere but these places where it has vertical asymptotes. Okay, so I'm going to go back to the graph and summarize all this stuff. So let me stop the share. So we're going to look at the tangent function. We saw that the domain is going to be all real numbers except plus or minus pi over 2, where there's a vertical asymptote, plus or minus 3 pi over 2, where there's a vertical asymptote, and so forth. It has vertical asymptotes. At these values. Notice that the sine and cosine didn't have any. Okay, and this keeps going on, it's etc. Okay, the range, minus infinity to infinity. The period is going to be pi. It repeats itself, the graph repeats every pi. And the amplitude doesn't make sense. The amplitude would be infinity, but it really doesn't make any sense to talk about that. Okay, so that's our tangent. I'm going to take one more look at the graph. So we'll do one more screen share, and I'm going to say a couple more things, and that'll be it. So let's look at that. Again, if you look at all these things, here, let's kind of pan out a little bit. Let's get it so it's centered, and we'll pan out a little bit. The domain is all real numbers except for the vertical asymptotes. We saw where those were. The range is minus infinity because as x approaches pi over 2, tan x approaches infinity. And as x approaches minus pi over 2, tan x approaches minus infinity. Okay. The period is pi, you can see that. It just repeats itself, and the amplitude is infinity. Okay. So just one more final summary. If you want to take another look at it, the domain is all real numbers except where there's vertical asymptotes. The range is minus infinity to infinity. And as x approaches pi over 2, 3 pi over 2, 5 pi over 2, the tan x approaches infinity. As x approaches minus pi over 2, etc., the tan x is going to approach minus infinity. Okay. Period is pi because the graph repeats itself every pi units, and the amplitude is infinity, but we really don't talk about it because it doesn't really make sense to. Okay, that's going to be it. Let me say goodbye. We'll have a video where we do some problems.